everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 47 should come up on your screen. It says compute the standard deviation for the data sample. Use the sample standard deviation shortcut formula. However, the extra task that I'm asking you to do is get a bell curve ready after you find your standard deviation. And the data given is 283, 55, 32, and 10. All right, let's get cracking. Shouldn't take you more than 6 minutes. Yep. Okay, go. All right, here we go. For the sake of time, let's get started. You should be just about done. Double check with your neighbor. However, who did we say was going to get us started? Martin. All right, so the sum of x. Martin, what'd you get? The sum of x. Close. $120. Hands if you got that. That is correct. All right. But also we need the sum of the data x squared. Whew. Whew. Martin, pass them one. AJ, what'd you get for the sum of the squared of each of those numbers? Are you start working it out? All right, so let's pass it back to Martin. Martin, what's our mean? Because we need it for the bell curve. Let me get the bell curve going and tell your neighbor, guys, what you got for the mean on that bell curve. All right. Good conversations. Martin, mean. 30. Well, 30 hands if you got 30. That is correct. 120 divided by 4 data, that's 30. All right. So, we pass it back to who, Martin? No, pass it back to who? AJ. Sum of x squared. All right. So that's about to wait for AJ. In the meantime, let me get my bell curve ready. First standard deviation, second standard deviation. All right. What'd you get, AJ? What do you guys say? Bruh. Well, let me help you. This is 100. This is 32 times 32. That's 9,000. No, 10,000? No, 1,000. Sorry. 1,000 something, yeah? All right, go. For the sum. Yeah. 1,123. Yeah. Let's go. Hands if you got that. No? My goodness. All right, let's do 23 squared, AJ. What'd you get for 23 squared? $549. What is 55 squared? 3,025. What'd you get for 32 squared? 5,024. 1,024. Plus 100. All right, so what is the sum of that, AJ? Oh, 529? Okay, my bad. 529. 529. All right? So what did you get? $4,600 and what? 78. Hands if you got that. Woo! My goodness. All right, and then you substitute that into your formula, and by now you should have your standard deviation. Is that correct? All right, check with your neighbor for standard deviation. Oh, this is the sample. Sorry. What'd you get for standard deviation? All right. And pass on one, AJ. Darian, what'd you get? Bless you. All right. All right, while we wait for Darian, go ahead and go to Canvas, turn in your home plate from last night. Let me pause the video really quick. Bye. All right. So Darian said he was going to pass it, so let's pass it. Let's see somebody different. How about Adisai? Okay, Adisai, what'd you get for standard deviation? 18.96 without hesitation. Hands, have you got that? That is correct. Approximately. Put the wiggles. So that means one standard deviation up, we should be at 48.96. One standard deviation down, we should be at 11.04. That's our norm. Send that in, please. All right, copy the agenda. Warm-up number 47, measure the variation. In parentheses, write coefficient. Today we're going to cover something called the coefficient of variation. I'll explain that as soon as we get there. Tonight's home plate page 145, numbers 27, 29, and 30 only. All right, and hopefully from last night should have been a piece of cake, yeah? Yes, Mr. Q. All right, good. All right, and send the agenda to your screen. And then copy this code for your home plate axis, 6PJ9S. 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 Once again, last night's home plate were these 4 problems. But if you turned in most of number 17 yesterday in class, you just need to turn in 1 more of these, right? All right, good. Home plate for tonight looks like this. It's only 3 problems. Let's go. Let's go. All right? Get a Cornell note ready, please. Our objective for today, I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. And I'll give you guys a minute to turn in your home plate. Hurry up, please. Yes, Celeste? Shall we? Here we go. By now, you should know what the measures of variation are. Is that correct? You don't even need to check with your neighbor, so type it in on your screen. You got 30 seconds. Type in a definition in your own words. Measures of variation. Go. 6, 5, 4, 3, 2, 1. Here goes from one of your colleagues. They just wrote distribution of data. Yes, but what is the key word that they forgot? Keyword. Goes in sandwiches. Spread. My goodness. All right. Next. By now you know these by heart. Fill that in. 45 seconds. Go. Let's go is correct. Jay. 10. Yes. 9. 8. 7. 6. 5. 4. 3. 2, 1. All right, thank you. It should look something like this. Yes? All right. And of course you guys know all your formulas. Is that correct? How many do we have? 16 of them by now. Because the next pop party that's coming up. So, turn to the back of your notebook. Today we're going to add 2 more. Let's go. Let's go, Anthony. Oh, yeah, we got this. Yeah. What's that? I shouldn't because it's my birthday month. We should have one every week because it's my birthday month. How about them apples? Let's go. All right, copy these 2. And it says CVar equals S over X bar times 100. The other one is CVar equals low cap sigma over mu times 100. So just copy it. By now you should know what those symbols are, except for the CVar. I'll explain CVar. Copy that? All right. Let me pause the music just to elaborate on this. So, before I ask Martin, look up please. By now, look up. By now you should know what this stands for, this stands for, this stands for, and that stands for. Talk it over your neighbor. What do those stand for? Talk it over your neighbor. All right, good combo. All right, let's go. Who do we say we're going? Martin. All right, Martin, what does this one stand for? Sample what? It doesn't have the square. Standard deviation, that is correct. Label that, please. Standard deviation. Yeah, variance has the little square on it. Okay. How about the bottom part? Martin. Sample mean, that is correct. Sample mean. All right. How about this side? Let's see, how about Martin? If this is sample, that means this is sample standard deviation. That means this is population standard deviation. That is correct. Label that. All right. And of course, look up, guys. If this is sample standard deviation, this became population standard deviation. So that means if this is sample mean, what is this, Martin? Population mean. That is correct. All right. Now, Mr. Q, what is coefficient variation? Well, according to what it says there, statistics that allows you to compare standard deviations with different units, which is good. But what does that mean? What it means is this. Watch. Has it happened to you guys, let's see, that, let's say, you did some work for someone, maybe in your family, and then a sibling of yours does something else, right? And then when they gave you guys some money, they gave you guys the same amount. And you're like, that's not fair. How come I get I washed the truck, I mowed the lawn, I clean, and I vacuum, and homie over here only picked up the kitchen, and you gave him the same amount of money? Has that happened to you guys? Well, guess what? Coefficient variation helps us to kind of balance that out and make sure we have the same type of formula that's going to help us calculate that. However, variation means this, that the one with the highest percentage means that it has a higher variation. What does that mean? That it's not stable. That means that it can vary from way over here to way over here on percentages. Whereas if you have something that has a smaller variation, that means it's more stable. It only varies from here to here, smaller variation. Does that make sense? So if you have something that has a bunch of variation, it could be a bunch of numbers that you can choose from, whereas smaller variation is more stable because you choose from smaller amounts of variables. Straightforward? Yes? Yes, Mr. Q. All right, copy this next one, please. Actually, before that, send me a picture of your formulas to make sure you copy those. I want to see where you're at with your formulas. And thank you, Martin, for helping us out with that. Appreciate it. Because I wonder who's going to help me with this next one. All right, copy that one onto your notes, please, completely, because I do want you guys to have at least one example of these. And it reads, example Q, the mean of the number of sales of cars over a 3-month period is 87, and the standard deviation is 5. The mean of the commissions is 5,225, and the standard deviation is 773. Compare the variations of the two. I'll give you guys some time for that. Copy that. 2 minutes. All right. And you pause the music as you're finishing up copying that, and it reads again. Example Q, the mean of number of sales of cars over a 3-month period is 87, and the standard deviation is 5. Question, are they saying sales for the entire United States? No. Okay. The mean of the commissions is 5,225, and the standard deviation is 773. Compare the variations of the two. Whenever you get to these problems that it says compare the variations, do they say use the coefficient variation formula? No, they're just asking for the variation. Whenever a problem asks you for variation, automatically you think what? CVar. However, which formula do we use? Tell your neighbor which formula do you use and why you chose that formula. Tell your neighbor, which one do we use? All right, good conversation. Looks like JJ's got this one. All right, JJ, which formula do we use from the two that you copied? Are you in here? Oh, you stepped out? Okay, let's pass it to Jay. Which one do we use? Let me get you started. CVar. What? S over X bar. Hands, do you agree with that? That is correct, because we're using a sample, not an entire population. That is correct. So, I'm going to use two colors. If you have your color pens, use them. I'm going to start with blue. I'm going to read the problem, and we're going to underline the first portion of the information that they give us. With blue, it says, the mean of number of sales. So underline the word mean in blue. And they're talking about the what? Number of sales. What is the mean? What do they give us for the mean? Everyone? 87. Okay, so we got that. This is our mean. So that means we label that X bar. And then it says the standard deviation is what? 5. So we label that S. So that's for blue. So I'm going to use, underneath that, you're going to write CVar equals blank. And instead of S for standard deviation, what do we write, everyone? 5. And for the X bar, we write 87. All right. So calculators calculates. Oh, what are we missing, by the way? Sorry. What was I missing here? Times 100. All right. So calculators calculate. 5 divided by 87 times 100. And we get, Jay, pass them one. Darian, what'd you get? 1. What is it? 5.7? 5.74. Since we multiply times 100, what does that make that number? Tell your neighbor. When we multiply times 100, what does that make that number? No. We're good right there. But I'm saying, what is this if we multiply times 100? Think about it. It makes it a what? A percent. Percent. We did that with the pi. Is that correct? We multiplied times 100. It made it into a percent. All right. So let's switch to green. Let's go to the next part of the problem. It says the mean for what? Commissions is how much? 5,225. So that's the mean. So we write X bar again. And the standard deviation is 773. So that's our S. So we write it again. CVar equals times 100. Darian, pass someone so they can help me set this up. AJ, tell me what you write. Hands if you agree with that. Close. All right, let's try again. Ooh-wee. And times 100. All right, AJ, calculate that. 773 divided by 5,225 times 100. Go. 14.79 what? That is correct. Hands, have you got that? So question, which one of those has more variation? More variation, obvious. Which one is the obvious that has more variation? Which one? The bottom one. So label this one, put a little arrow, meaning that it has more variation. So out of these two, which one is more stable in regards to the percentages that it's giving us? The more stable would be what? The 5.74. Just write next to it, stable. Stable. Why? Because the more it has percentages that it varies, that means that one day you can, in regards to the commission, you can commission, maybe you don't sell anything, you get nothing that day. Whereas the next time you can sell two things and get maybe 2,000. You know what I'm saying? So that's why this is the one that you go with the most. From 1 to 5, how comfortable are you with this? 5 4s, 5 4s. Okay, send me your notes, please. And I'm moving on to example Omega Q. And for this one, I'm going to have you, actually, we're going to do this one together because this one has like a little slider to it. Let's see if you catch it, okay? And it reads, example Omega Q, the mean for the number of pages of a sample of Woman Fitness magazine is 132 with a variance of 23. The mean for the number of advertisements of a sample of a Women's Fitness magazine is 182 with a variance of 62. Compare the variation. So since we heard the word sample, that means we use again CVar equals S over X bar times 100. All right? And once again, I'm going to use blue for the first part, CVar blank over blank times 100. And green for the second part, CVar equals blank over blank times 100. All right, so let me send that to your screen. All right, so this is what I want you to do. On the screen, I want you to underline in blue the information that we need from that problem. Do that on your screen, please. Underline the information that we need in blue. Information that we need in blue. Underline that, please. And then who went last? Darian? AJ? Sure, Martin. All right. So help us with the first part. It says the mean for the number of pages of the sample Woman's Fitness magazine is 132. So where do I write that? There, Martin. What else does it say? With a variance of what? 23. Where do I write that? On top, let's see. Look up, please. Hands if you agree with that. Close. Writing utensils down. Writing utensils down. Look up to the screen. Martin said that the mean is 132. But the formula says standard deviation goes on top. And what did we write on top? Think about it. Don't say it out loud. Think about it. What do we need to do? What do we need to do to this number to get the standard deviation? If this number is a variance. Talk to your neighbor. What can we do to that number to get the standard deviation if that's the variance? All right, let's see. Looks like Rianne knows what to do. What do we do, Rianne? Square root. That is correct. Yes. Remember, the variance, let me write this over here. Look up. Make a little note for yourself. The variance is s squared equals to 23. But to cancel this squared, what do? Take the square root, and that's how we find our S, or standard deviation. Okay? So calculators calculate. What's the percentage for the first CVar? Rianne, pass someone. Matthew. Square root of 23 divided by 132 times 100. 3.62%. Hands if you got something like that. All right, good. All right, so do the last part by yourself, the second CVar. I'll give you some time, 1 minute. Go. As soon as you're done, send me a picture of your work. And remember, make sure you indicate which one has the most variation and which one is the stable one. All right, Matthew, pass someone so they can help me with the green one. Noah, what do I underline? The mean is how much? 182. That's my X bar, okay? And the variance is 62. So tell me what to write. 62. 182. Square root 62. So what'd you get for percentage for this? 12.32? 4.32. Okay. 4.32%. So obviously this is the one with more variation. And again, which one's the stable one, everyone? This one. Stable. More stable. Even though they're pretty close, but still makes a difference, that little extra variation. Okay? From 1 to 5, how comfortable are you with that so far? 5, 5, 5, 4. Okay, we got this. Make sure you send that in, please. All right, copy this table for the last problem. Here we go, example super Q. It says subject matter, mathematics, science, social science. The mean for mathematics, 56. Science is 65. Social science is 60. Standard deviation for mathematics is 12. For science is 14. And for social science is 10. So, I want you to make an extra column. And I want you to label that CVar. Actually, no. I know what. Let's do this. Look up. Yeah, let's leave it as CVar. So find me the CVar for each of those. Let me send that to your screen. I'll have you do that by yourself for each of those. There's 3 CVars that you need to make. Is that correct? Yes, Mr. Q. And find which one has the most variation and which one's the more stable out of the 3. Which one do you guys think will be the most stable out of the 3? What? No, I think mathematics would. Right, Martin? And it reads, example super Q, the mean and standard deviation of the marks obtained by 40 students of the class is in 3 subjects, mathematics, science, and social science, are given below. Which of the 3 subjects shows highest variation? All right. So, copy and go. I'll wait for you guys. Let's see, 3 things. How about 4 minutes, yeah? Yes, Mr. Q. All right, go. All right, you should be done with the mathematics by now for CVar. I'm going to put a percentage on top of CVar so you can just give me the percentage. All right, let's see, mathematics. What'd you get for the CVar, Alyssa? 21 point what? 43? 43%. Hands, have you got something like that? That's about right. Science. Pass on one, Alyssa. Mitos, what'd you get for science? 21 point what? 53. All right, hands, have you got that? Looks about right. And the last one, pass on one, Mitos. 16.16%. Looks about right. So, out of all of those, which one has the most variation? Yeah, science. And which one is the most stable? Stable, that is correct. Send that in, please. All right. So I'm going to send you your home plate to your screen. Those of you that are following on YouTube, there it is. It's 3 problems for practice. Enjoy. See you guys next time. Peace.